Okay, last day, whatever you have done, that is these all things, isn't it? You can see there what is given classification of elements you have done, and in classification of elements, we will straight away start with periodic table. So, modern periodic table uh, is based on atomic numbers. We did the law, and then what does it mean? Periodic functions. Periodic function means they are repeated in a certain interval. So after the eight elements, the ninth one and the first one had the same properties, isn't it? So that's why what was done, it was arranged in this way. Clear? So this we had done. Then apart from that, I gave you the basic structure. Isn't it? With all this, I have told you your periodic table is completely based on electronic configuration. So we saw these things. It is exactly based on what the electronic configuration is given, isn't it? These different points, whatever points I had given you, that you have to go through it. Clear? Then next, what we did all these things, S and P block together, they are called representative or normal elements. D block, they are called transition elements. F block, inner transition elements or rare earth elements. Clear? And F block contains the 4F series, that is lanthanoids, and the 5F series, that is the actinoids. The general configuration of S block was NS1 or 2 electrons. So this way, P block NS2 NP1 to 6. D block N minus 1D 1 to 10 NS1 or 2. And F block N minus 2 F14. And then you had, and then F was inside one, N minus 2 F1 to 14, N minus 1 D02, and NS2. So you can see two steps inside. Clear? So is one step inside, F is two step inside. So this we had done. Then we went into groups, different groups. The groups are vertical columns. Elements in the same group have same properties. 18 groups are there. The valence shell configuration is same, isn't it? And therefore the properties are same. These groups, they have certain names. These names I have already given you. They are alkali metals, alkaline earth metals, and all those things. So you have to know. Clear? Now, the next thing was periods. I gave you about periods. What are periods and all those things, isn't it? The vertical columns were called groups. Then the horizontal rows were called periods. There were 7 periods. These 7 periods, how many elements are there? And what are the names given to them? That we had done, isn't it? So till here we had done last day. So from here we'll continue now. Understood? So we'll see some properties of these things and then we'll continue with the properties in the periodic table. So uh, up till here you had done last day. Any problem? Then you will always let me know if there's any problem till now. Anyone? No. Then we'll continue to the new one now. Okay. Uh, Last day I told you uh, these elements, whatever elements are there, we have filled up to period 7. Period 7 is completely filled. That means 32 elements are already there. And that is not the end. If some more elements are discovered, then they generally go to the next group. That means there'll be one more period that will become eighth period. But up till now, we don't have the eighth period. Yeah. Now, since these things will keep on going on, new elements will be discovered again and again. So what will happen? Whenever elements are discovered, there's one thing which you have to know is how to name these elements. So naming of these elements, there is a particular system of naming. First, we'll see how to name the elements. Clear? We'll see how to name the elements. So the next thing which we are going to do will be this. We'll see these things now. IUPAC nomenclature of elements having atomic number more than 100. So whenever new elements are discovered, actually as they are discovered, then certain names, we already have a system which can name the element. Once it is named, then the actual name is given later on. Seeing the properties and other things, later on the actual name is given to the element. But as the element we are discovering, seeing the atomic number itself, we can always name them. Clear? So this naming, how this naming is done, we'll see that first, and then we'll see some more things here. So what you have to know here is this. Look here. When I want to name this, it is based on atomic numbers. So numbers, whenever we take numbers, how many digits are there? Can you let me know? Altogether, how many digits are there? Altogether, if I talk about the digits, how many digits are there? Altogether, you have 10 digits. The 10 digits are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. These are the different digits. These are the different digits which you have, and these digits, if we take, then these digits, they already have some names. Into the naming of elements. Remember, all these elements, which new elements are discovered, then they are named, and those names are given according to the atomic number which they have. Atomic number till 100. These elements are already discovered. Beyond 100, whatever is discovered, like many are already discovered, but if any new element is discovered, we can always name them. That system of naming is IUPAC nomenclature. Clear? Now this IUPAC nomenclature, when we take, then in this case, what will happen? We have taken the different digits. These digits, what are they? 1, 2, 3, 4, up to 10 digits are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. All other numbers, if you take any other number, then all those numbers are repetition of these digits. If you repeat these digits again and again, then you get all the numbers. So all numbers in this world are made from these digits only. Clear? And these digits, they already have some names. Clear? So those names will take, and from those names only will derive the official name of the element. Clear? So to find out the name, like IUPAC name, we'll find out, and the official name that can be given later on. But IUPAC names, we can easily write it down. Clear? So to know about this, we take the names like this way. Look here, digits. These digits, they have certain names, isn't it? If I say one, one is called uni. You know that. So generally we write U N. Two, two means by. Three means try, isn't it? Four means quad. Five means pent. Six means hex. Seven means sept. Eight means oct. Nine means n, E N N. and 0. 0 means nil. We are used to writing nil, isn't it? So these are names obtained from the Latin source actually. Clear? So when we take this, these are the different digits and the names. Now these names, if I take un, by, try, and so on, these names, if I just take the first letter, then the first letter for the first one is U, the second one is B, the third one is T, fourth one is Q, isn't it? Next one is P, H, S, O, E, and N. These are the different digits. The first letter I've taken, you'll see none of them, they are repeated, isn't it? All are different. So we'll take this to use the, to find the, to write the names, and we'll use this to write the symbols also. So these are used for names and these are used for symbols. So these two we are going to use it. Clear? So how is it used? Let's see. Okay, so how this is used. uh, to use it, look here, suppose I say anything atomic number more than 100. More than 100 means 101. So when I take this, we name according to this only. It is 1 I'll write down UN. Then 0 I'll write down NIL. Then again it is 1 means UN. Un, nil, un. That is coming from 101, isn't it? And at the end, we always add IUM. So basically, what is happening? 1 is there, 0 is there, 1 is there. So UN, NIL, then UN. And with this, we always add IUM. In all cases, we have to add up IUM. So what will this be? Nil Anyam. So 101 will be called Nil Anyam. This is your name. And while writing the name, you'll always see the first letter will be written in capital and all others will be in small letters. Clear? So the first letter is always in capital. Clear? The first letter is always in capital. Always remember that. First letter in capital and the rest in small, and no gaps. In between there should not be any gap. So anil, anyam is one word. Clear? How it is coming? An from 1, nil from 0, un from 1, and IUM is always added there. Understood? So this is your name. What will be the symbol if I ask you that? Then what will it be? If the symbol is asked, this is your name. Anil, Anyam is your name. So from this, we should be able to write the symbol also, isn't it? Okay, to write the symbol, what will I do? I'll just take the symbols U, B, T, all those things, and just write down the symbol. So to write down the symbol, the first one is 1. 1 means I'll take U. Then second one is 0. So I'll write down N. And again 1 means U. Again the first letter is capital and the rest all are small. Clear? So first letter capital, all others small. So U, N, U if I write, that means that is the element with atomic number 101. Had it been 102, what will be the name and symbol? All of you write it down. You all write it down, then I will show you what exactly it is. Can you write it down, all of you? Write it down and let me know how much. Anyone? Samprikta?
So it is UNL BM and the symbol is UNB.
So what will I write down here? One. One means I'll write down UN. Then zero. Zero means NIL, isn't it? And two. Two means BI. Understood? And then at the end, what is added? IUM. But here, this is already ending with I. I'll just use UM. The BI was already there. We don't repeat I. It's simply by BIUM. So the formula is not the formula, the symbol. Symbol will be UNB. Is it correct? Anyone, any problem?
No, sir.
Anthony? Nothing. Okay. If I'd given you, suddenly, suppose I give you any other number. Suppose I say 118. What is the name of this? Hurry up. 118.
So un octium and the symbol will be UUC. No, UUO.
Oh, okay, look here. One means UN, again UN. Eight means OCT, and then IUM. And since it is what is called one, we'll write U, then again one, and then O. So UUO is your symbol. Clear? It can be any number. Remember, 118 elements are there altogether, but new elements. Suppose a element comes with 1, 2, 4. Then what name will you give it to you? What name will you give? 124. What will be the name given?
So it will be un by quadium.
Simple one. 1. Whenever it is 1, I'll write down UN. And then 2. 2 means BI. And then 4. 4 means QUAD. Isn't it? And then IUM. Symbol UBQ. Is it clear? Now let's take the other way. Suppose I say an element. We have an element and that element is UNO. What is the atomic number and what is the name? What is the atomic number and what is the name?
Atomic number is 108 and the name is Sir Unnil Octium.
So what will this be? When I write this, then in this case it will be 1 because U means 1, N means 0, and O means 8. So 108, it is un nil octium. Clear? If suppose I just write down anything, suppose it was BQN, then
So it will be atomic number will be 240.
Yes. Atomic number, as you are saying, B will be 2, and Q means,
It will be biquad octium.
and this is N means 0. So it will be bi quad nil IUM.
Yes, and nil. Oh, oh, yes,
Isn't it? O 0
yes,
means
yes,
nil.
yes.
Biquadnilium. Is it clear? Anyone has any problem? You let me know. This thing comes in your examination, 1 mark. It will come. It's very easy also. You just have to know the name of these digits. Anyone has any problem in this? Just let me know. Nothing. Then we go to the next part of this chapter. This part will end up, isn't it? You have already done this, so we can continue with other things now. Any problem here? No. So let's start with something else. Okay, we can talk about this. Characteristics of characteristics of uh, suppose I say S block elements. What can you say about the characteristics? Just tell me quickly. First one, I can always say that electronic configuration. What will be the electronic configuration? The outermost I gave you today only. It is NS1 or 2. If it is 1, it is alkali metals, and if it is 2, it is alkaline earth metals. Isn't it? The second thing you can say, they all have low ionization enthalpy. Whenever I say enthalpy, it is energy. So low ionization enthalpy. And with this, I can also add they have high, highly electropositive. The electropositive means they have a tendency to form positive ion. They can easily lose electrons. Clear? So third one, they can easily lose electron. So lose electron means they are easily oxidized. So they are good reducing agents. Strong reducing. These all things one by one I told you last day also. Clear? Why strong reducing agent? They, as they lose electron easily, as they lose electron easily, that means they are easily oxidized, isn't it? Then the fourth one, I told you last day also, forms They easily form ionic compounds. Clear? The fifth one, they are good conductors of heat and electricity. Okay. Six will be they impart color to the flame when heated. If you're heating them directly in a flame, then they give a particular color to the flame. The flame becomes colored. Okay. Then the next thing I can write down is they are most metallic, isn't it? The most metallic and metallic character increases downwards. As you go downward, the metallic character will increase. Clear? And then number eight, they are soft metals. Metals are generally hard, but these are soft. Why they are soft? Because they have low melting point and low boiling point. The melting point, boiling point are low. Have you all copied? Hurry up. Have you all finished? I'll change. Okay, I'll change to the next one. The next thing, conductors. P block elements. The first one, as usual, will write down electronic configuration. NS will have 2, NP 1 to 6. Yeah, the second one. If I take them, then they consist of metals as well as non-metals. Consist of metals as well as mostly they are non-metals. Yeah, metallic character decreases along the period, but increases down the group. As you go downward, metallic character will be more. Then the third point, they have ionization enthalpies more than S block. Whatever is the enthalpy of S block, this will have more than that. Okay, then they form covalent compounds. Again, when we say ionic or covalent, it's not always. Most of the compounds are covalent. Okay, then number 5, they show more than one oxidation state. It's not only one, but they can show more than one. That means they have variable valencies. They can show more than one oxidation state. Okay, then the next one. If we talk about oxidation, the oxidizing character increases from left to right. Oxidation character increases from left to right. As you're going rightwards, the character will be more, but the reducing character increases top to bottom. So top to bottom, reducing character is becoming more. Okay, then number 7, if I take them, then these are acidic in nature. Clear? So these are the characteristics of P block. Then let's take the other one. All of you have copied, isn't it? Then I'll write down characteristics of D block elements. The first one will write the same thing, the electronic configuration. What will it be? N minus 1, D1 to 10. Then NS1 to 2. Okay, they are metals. So metals, since they are metals, what will happen? Are hard, malleable, ductile. These all are properties of metal, isn't it? So they are hard, they are malleable, they are ductile. Malleable means they can be beaten into sheets, and ductile means they can be drawn into wires. Number three, they have high melting point and high boiling point. Melting point, boiling point is high. They are metals, so they are good conductors of electricity. Here also they show they exhibit variable oxidation state. They also show variable valency, in other words. They form ionic as well as covalent compounds. They can form ionic compounds also, they can form covalent compounds also. Okay, their compounds are generally colored. The compounds, whatever compounds they are forming, they'll be colored. Then the next thing, you'll see most of the time they act as a catalyst. You'll see most of the time we are using a catalyst, it will belong from these things only. Clear? They form alloys and these things, and I can also write down one more thing, interstitial compounds. We'll come to these interstitial compounds later on again. These compounds are generally formed by trapping certain elements, certain atoms in the intermolecular spaces. Whatever space is the intermolecular space, they trap some element and they form these type of compounds. And then one last one, that is they are paramagnetic. They are paramagnetic as they contain unpaired electrons. They contain unpaired electrons, so they are paramagnetic. Paramagnetic is a magnetic behavior, the behavior in a magnetic field. Magnetic field, they may be attracted or they may be repelled, so weakly or strongly. So if you consider all these properties, you have paramagnetism, you have diamagnetism, ferromagnetism, these all things are there. Clear? So paramagnetism, they are weakly attracted by magnets. If it was diamagnetism, they're weakly repelled by magnets. This paramagnetism comes when they contain unpaired electron. And if they don't contain any unpaired electron, then we call it diamagnetism. Is it clear? So this is your characteristics of D block. Then we'll take one more. That is the last one. Your characteristics of F block elements. You take F block again, the first thing is always electronic configuration. What will it be? N minus 2, F1 to 14, then N minus 1, D, which can be 0 to 2, then N S, and that NS will have always 2 electrons. So this is your general configuration. The second thing, they are heavy metals. That means the density will be high. The heavy metals, clear? High density. The next one, high melting point. Melting point is very high, so boiling point will also be very high. They also exhibit variable oxidation state. These also forms colored compounds. Clear? Exhibits variable, but if I take here, then most common is +3. Oxidation state, they can show many, but the most common among all of them is +3. These are also paramagnetic in nature. That means contains unpaired electron. Contains and then number 7, lanthanoids. Lanthanoids are normal metals only, but if I take the next one, actinoids are radioactive. That means they start decaying. They give out radiations like alpha, beta, and gamma. Done, all of you? So these are the general characteristics which I have given you. Okay, now the next thing is The next part is more important here. Now, whatever you are going to do, they are in fact very important. Clear? In periodic table, what is the periodic table? The general characteristics and other things we have seen. Now, this periodic table mainly it is known for its periodicity of properties. Okay, so here mainly we are going to do that now. So what we'll do is periodicity of properties in a modern periodic table. In will not be there in modern periodic table. So to study about these properties, I'll just give you one example here of a period and a group, and then we'll go into the properties, because to know about the properties you just have to know about a few points here. So let's take an example. Suppose I say period, suppose 3. Period 3 starts with sodium, then magnesium, aluminium. You should be knowing. Can you tell me? You should be able to tell me what things are there. By now, you should have learned it. Yes or no? If not, then learn it.
So there is silicon,
Then
phosphorus,
phosphorus. Then
sulfur,
yes, phosphorus. Then sulfur. Hurry up.
and chlorine,
Chlorine, and then comes
argon, argon.
yes. These are the things which are present in period 3. Clear? Now this period 3, when we take this, then what is the atomic number? This is 11, 12, 13, 14, 15, 16, 17, and 18. I can take the electronic configuration. You can write in terms of S, P, D, and F, but I'll just write down so that we'll know the number of shells only. We are just writing the shells. Okay, so if I take this, it will be 281. This will be 282, 283, 284, 285, 286, 287, 288. I'm writing this so that we just get the idea about the number of shells they have. Okay, then the next one which we have is we'll take valency. If I talk about valency, it is the number of electrons which are gained or lost. If I take the first one, it will lose 1, lose 2, lose 3. Whatever is in the outermost, that much it is losing. But 4, neither it will gain nor it will lose. So 4 is shared electron. Then this will gain 3, gain 2, gain 1, this one, no change. So usually what happens when I take all these things, this portion is not having any properties. The valency is 0, so we don't consider these things. Rest we are considering. Clear? Noble gases, they don't react. So when we talk about many properties, they don't behave as other elements. Clear? So this is your period. I've taken one period, and let's take a group also here. Group 1, suppose I take. Then in group 1, you have hydrogen, lithium, then sodium, potassium, rubidium, cesium. It keeps on going. Clear? We just need an idea. So when I take this, these are the elements. Now they'll also have atomic number. Atomic number of hydrogen is 1, lithium is 3, sodium is 11, and potassium is 19. They'll also have electronic configuration. This will remain 1, 2, and 1. Then 2, 8, 1, 2, 8, 8, 1. This is how you have studied in lower classes also, isn't it? And then comes valency is 1, 1, 1, 1. Okay, we just got an idea about a group and a period. From this, we'll just predict a few things. Up till now, whatever you can see on the screen, you can easily see what is happening in a group and what is happening in a period. So we'll be referring to this, and at the same time, with reference to this, we'll talk about some more properties. Clear? So if I talk about the properties here, then one of the property which I'll talk about is this atomic number. You can see here atomic number. What is happening? This is 11, 12, 13, 14. So as you are going towards the right, what is happening? It is going on increasing. So atomic number, if I take it like this way, this side, from left to right along a period, just what is happening, you should have an idea what is happening. When you're going from left to right along a period, it was 11, then 12, 13, 14. That means it is simply increasing. So I'll just write down increases here. From left to right, it increases. And same thing, I'll take top to bottom. Top to bottom down a group. What is happening? Tell me. You're going downwards. 1, 3, 11, 19. What will happen? This way also it is increasing. So atomic number on either side, it is increasing. Now why we did atomic number is because this atomic number is related to a very important property which will dominate in the periodic table. That very important property is called nuclear charge. So this atomic number is similar to nuclear charge. Nuclear charge means what? Charge on the nucleus. If you take the nucleus, it has some charges, and that charge, what type of charge will it have? Positive or negative? Tell me. Will it have a negative or a positive charge? Anyone? Nucleus is positively charged or negatively charged?
So positive.
Positive. Why? Because nucleus is made up of protons and neutrons. Clear? Neutron protons are positive. So the whole nucleus is positive. And that positive, how much positive charge is there that we are talking about is nuclear charge, isn't it? So if I take this nuclear charge is same as atomic number. because atomic number increases means the number of protons increases, and protons are increasing means atomic number is also increasing. So if I take nuclear charge, then this nuclear charge left to right increases, and top to bottom also increases. Left to right, the nuclear charge is becoming more, and top to bottom also the nuclear charge is becoming more. So one thing which you have known is the nuclear charge, how it is changing, isn't it? Atomic number relates to nuclear charge, and nuclear charge is increasing left to right as well as top to bottom. Clear? Now, from this, I'll give you uh, another property now. If I had asked you about uh, number of shells, what is happening to number of shells left to right and top to bottom? Just now we did something here. What can you say about the number of shells? Number of shells left to right and number of shells top to bottom. You can clearly see here number of shell. How much? 281 means KLM. There are three shells. Here also there are three. Three. So what is happening? As you are going
It
from,
remains the same.
yes, it is remaining the same, isn't it? Left to right, there's no change in the number of shells. But as you go downwards, if I see here, this had one, here you have two, three, four. So what is happening as you are going downwards? The number of shells are increasing, isn't it? So what will I write here? If I take number of shells, then what should I write? Number of shells left to right. Left to right, the number of shells. Just now I told you remains the same. So number of shells left to right remains the same, and top to bottom it increases, isn't it? Then one more thing we'll see is number of valence electrons. Number of valence electron means number of electrons in the outermost shell. How many electrons in the outermost shell? To know about this, let's see whatever we did that time. This will give you the idea of what is happening. What can you say? Number of valence electron. If you see here, valence electron means how much is there? 1. Here it is 2, 3, 4, 5, 6, 7, and 8. So what is happening as you are going from left to right? Number of valence electron is increasing, isn't it? And if I see here 1, 1, 1, 1, so what is happening? From top to bottom, the number of valence electron is remaining the same. So if I have to write down here, what will I write? If I take this left to right, increases, and top to bottom remains the same. So left to right increases, top to bottom it remains the same. And from this, one more thing, let's do it here. Valency. Valency is the number of electrons gained or lost or shared during the chemical bonding. It's actually the combining capacity of an element. How much combining capacity it has, that depends upon how many electrons it can gain, lose, or share. So if I take the valency, let's see again what is happening in the previous one. You can see here again what is happening. The valency is 1, 2, 3, 4. Up here it is increasing. But after that, what is happening? 3, 2, 1, 0. It starts decreasing also. So initially it increases and then decreases. But if I take here 1, 1, 1, 1, that means it remains the same, isn't it? So if I take this one, then in this case, what will I do? I'll write down from left to right, increases and then decreases. First it increases and then it decreases. In one word, I can write down it is cyclic in nature, increasing, decreasing, isn't it? And top to bottom, it remains same. So since the number of valence electron remains same, the valency also remains same. And therefore, the property of the elements down the group remains the same. We had already said elements in the same group have the same property. So here they're having the same properties. Understood? Okay, so all these things, any problem up till now?
No, sir.
So today we'll end up the class here only. Go through all these things. Okay. These all properties more or less you are done in class 10 also, but next day, whatever we are going to do, that will be completely different from whatever you did in class 10. So don't miss the class. That day we'll see. Clear?